Hello boys and girls, Mr. Giomini. Wanted to come to you with a couple examples on distributed property from Khan Academy. It seems like some of us are struggling with this, so I thought it'd be beneficial if I made a little video helping you out. Let's take a look. It says we can rewrite the expression 16 plus 8 as 8 times 2 plus 1. Notice that 8 is the greatest common factor, GCF, of 16 and 8. What they did is they essentially divided by 8 divided by 8. That's why they have the 8 on the outside now, because that's their common factor. And when you do 16 divided by 8, you get 2. You do 8 divided by 8, you get 1. Using the same theory, the same algorithm, I now have 24 plus 36. In my head now, I'm trying to figure out what is their greatest common factor. I believe it to be 4. What I'm going to do is divide both by 4. What that means now is I have a 4 on the outside. What I would then do is distribute that 4 inside to get back to 24. Now 24 divided by 4 is 6. The operation that they're using this expression is plus, so I will also use plus. And then 36 divided by 4 is 9. Now the first thing I notice is that 6 and 9 you can also pull a 3 out of. If I pull a 3 out of that, now I have 4 times 3 on the outside. Well, that's 12. So maybe the greatest common factor would not be 4, but instead it would be 12. Again, before I hit submit, I thought about my answers. Now if I pull 12 out of this, rather than dividing both by 4, I'll divide both by 12. 24 divided by 12 is 2. Again, they're using addition. 36 divided by 12 is 3. Let's take a look. So no longer is the greatest common factor 12 or 4, it's 12. I have 2 plus 3. Let's take a look. Okay. Similar problem. Gives me a model up here. Rewrite 20 plus 3 as 10 times 2 plus 3. What they did is they said the greatest common factor of 20 and 30 is 10. They pulled the 10 out, and they asked you, what did you multiply 10 by to get 20? 2. The operation using is addition, so I use addition in my parentheses. Let's take a look at 45 and 75. 45 and 75. Now again, it's important that I am good with my math facts. Let's just say that I did 5, because they both ended in a 5. Well, that would give me a 5 on the outside. 45 divided by 5 is 9, plus 45 or 75 divided by 15. I think that gives me, let's see here, 5 goes into 7 once with 2 left over. Doesn't that give me 15? Yes. But now I look at 9 and 15, and I say, wait a minute, their common factor is 3. So I'd pull a 3 out of this, making this now a 15, because 5 times 3 is 15. Now I'm going to divide both of these by 15 instead. I will still keep the parentheses. Now I ask myself, okay, 45 divided by 15 is 3, plus 75 divided by 15 is 5. These two have no common factors with the exception of 1. Now I have the answer of 15 times 3 plus 5. Do 2 more here. Okay, rewrite the expression 20 times 5 plus 9 as a sum of 20 and another whole number. Well, let me rewrite what they gave me. They gave me 4, and I don't like to put the multiplication symbol there, 4 times 5 plus 9. First thing I notice is I use a distributive property. I'm going to multiply this 4 by everything inside the parentheses. Well, now I see where they came up with a 20, because 5 times 4 is 20. And it says rewrite the expression as a sum of 20 and another whole number. They tell me sum, I know I'm going to add 20 and another whole number. Well, 4 times 9 is 36. I could do 20 plus 36. All right. Similar one that we did previously. They give us the model up here. I'm going to use a similar method now to use distributive property to show 15 plus 21. So the algorithm now I use, I'm going to figure out what's the greatest common factor of 15 and 21. I believe it to be 3. 15 divided by 3 is 5. I'm going to pull that 3 out here. Plus 21 by 3 is 7. 5 and 7 have no common factors. There's my final answer. Okay, hope this helps you out. Take care.